And apparently my pen is going just nuts. I'll do it over here. It only does that when somebody has a cell phone. Who has a cell phone? On you.
I don't have some.
Well, that's fine.
Wait, what is it?
Okay. How is area different than perimeter, Andrew? Area is,
Like everything in it, not just the outside.
yeah, kind of. But what do we measure it in? That's probably the best way to tell it.
Square units.
Yeah. Area is how many squares something has inside of it. And I always start by telling you, area is relative to the size of the squares you're talking about. Okay, the same shape can have an area of 4 million, or it could have an area of 4, depending on what size square you're trying to cut the thing into. For example, a square centimeter is like this. It's somewhere like that. A square centimeter, 1 centimeter square is a centimeter by a centimeter by a centimeter. If you wanted a square inch though, you're going to get a lot bigger. 1 inch squared. A square foot is a foot by a foot by a foot. If you look on the floor, those are square feet. And a square mile is a relatively large piece of land. If you think about it, it's from the corner of 47 all the way down. Those of you that are cross-country people, you gotta run all the way down to the corner of Emmanuel, and then run all the way to Walker Road, and then run all the way back. I mean, it's a long way to get around that. That's a square mile. Takes up a lot of room there. So that's why labels are important. When you do something in area, you have to give the label because somebody doesn't know. 4, what are you talking about? 4 inches, 4 square inches, 4 square feet, 4 square centimeters? Yes.
Is that a 2 or a 3?
Yeah. They're all 2s. Square units are always 2. Now, let's look at the formula. Okay, formula for the area of a rectangle. How do we find out how many squares of a certain size in there? Still using our L's and our W's. To do Bailey Lincoln, it is length times width. And formula for area of a square, if you think about it, a square has all exactly the same sides. Formula for area of a square actually is, well, we don't go SS anymore. It's true, S times S, but S times S in its mathematical, technological highest form is, I agree with your S times S or SS, but we call that, anytime you multiply the same thing by itself, it is, Emma Kunacek? S squared. Area equals side times side squared. Good for you? Good for me. Now, here you go. Because I didn't give you that, because you are 7th graders, we skip all the simple stuff and we go right to the tough problem. Write down this example. Let's go with this one right here. Let's say you've got a room, I guess, that is 12 feet by 9 feet by 8 feet by 3 feet by 4 feet by 12 feet. Okay, they don't go easy on you, they make it a little bit difficult. If I've got that shape and I want to find both its area and its perimeter, it's going to take a little bit of work. The perimeter will be easy because I think I've got all the measurements there. Actually, I should have got rid of one. What if I didn't know this was 3? Well, let's just say. What is the perimeter going to be? And again, by the way, let's refresh our memory here. If you see a problem like this on your paper or on the book, yeah, you don't have this drawn on your paper. What's going to happen, Phil?
Poem?
Ooh, a poem. Never thought of that.
You did, yeah, right
Who were my poets last year?
there.
Yeah.
Alex
Alex.
Yeah.
Alex.
If you don't wanna practice your poetry, just draw the thing, it's make your life easy. So the perimeter of this, and again, the reason you do it is so that you can mark off the stuff that you did. You'd add 4 plus 3 plus 8 plus 9 plus 12 plus 12. Now, for those of you that think along on a different level there's actually an easier way to do that. Anybody thinking as long as there's not a big concave or cave in it, as long as it looks like stairs. Remember, I think we talked about this. Nate?
That you can also just, add to
You're close. I think you're getting there. Ladies and gentlemen, the thing to realize is this. Okay, you've got this 12. This 3 and that 9 are going to give you an exact another 12. As long as it's a stair shape that doesn't have an indent in it, same thing with this. This 12 is going to be the same thing you get when you add those together. So really, in this case here, you just are adding 4 12s together, which I guarantee you, when you add this together, you're going to get 48 as well. 7, 15, 24, 36, 48. And again, this is just a unit of length, it's just 48 feet. That's not how many squares are inside that. We haven't done the area, we just did the perimeter. Okay, and the reason I told you this thing here, because you may sometime, I'm just going to do this, you may sometime come up to a shape that looks like this. And it'll give you, this is 10 feet and this is 14 feet. That's all you need to know to find the perimeter. That's it, because you add this plus this plus this plus this plus this plus this together, you bring all those down, you're going to get 14. You don't need to know what each one of them are because you end up adding them together anyway. So you got that 14, you got this 14, and the same thing is true for this one right here. If you add this going up, this all going up, you're going to get 10 for your total, no matter what you do. So you end up with whatever it is, 48 in the end. So don't be alarmed or confused by that. Now, here's where the trouble comes. In the area department, I do not have a formula that says how to find the area of a whatever this thing is, a square, a L-shaped thing. So when you don't have that formula, what do you have to do, Caroline? I like to use the words divide and conquer, like the conquistadors. In other words, I need to cut this shape into shapes that I do know how to find the area of. In this case, it's relatively simple because it's just going to be 2 rectangles. And it doesn't matter which way you cut it, I'll just do it like this for fun. I've got this rectangle here, and I've got this rectangle here. I find the area of each one of them and add it together, and that's going to be my total area. Now here's another word of caution. Okay, when you do the dimensions of these rectangles, this big rectangle, and you do your length times your width, you must understand this rectangle's side here isn't 12. That goes all the way down. You are stopping right here for this rectangle. So you have to use this 9 instead of that 12. It's 9 by 12. Oh boy. 9 by 12. 9. I'm going to do it down here. 9 by 12, which everybody can do in your head is? Anybody? 108, thank you.
Hey, you got there before me.
That's the big rectangle. Same thing for the little rectangle. I don't use 12 for this side right here. It is 3 by 4. You can't see that 3 too well because I didn't draw it very well. And that is 12. The total area, 108 plus 12, 120. And again, this is in feet. That's feet squared. You're talking about cutting it into squares that are all a foot by a foot. Charlie, did you get all that written down? Any of it written down? what percentage would you say of what I put on the board that you would have written down? For example, if I collected everybody's notes and graded them on, based on the stuff that I wrote that you put on your paper, your grade you feel would be a who? A C plus. And knowing that most people are very generous when it comes to grading themselves, Charlie, doesn't make me incredibly happy. Now, again, thinking on a little higher level, because in math there's a lot of different ways to do a problem here. Any other way I could have found the area to this one that may have been a little quicker? Because you could use this method as well. Nobody? Here's another way that you could have done it that might be a little faster. You could have, something is really strange. You could have thought of this thing as actually being a great big block, and then just remove the area of the piece that's not there. In other words, if you took the big square, the 12 by 12 square, you'd end up with an area of 144, and then you would just have to remove this little block here, which is a 3 by 8 block, minus the 24. You'll still get the same area that we got. Again, I will tell you this 1,000 times, children. You don't have to do things my way. Okay, if in your mind because there are different ways to look at math, feel free. If you can come up to me and show me how it works in your way, that's fine. However, you can never come up to me and say, I don't understand this, and not do it. At least try it my way. There's kind of a little meeting ground there. Okay, I don't like your way, but I can't understand it my way. Kendall, how?
Where did you get the 24 and why?
Well, because if you look at this whole block here, I don't have this corner. It's gone. When I did my 12 times 12, Kendall, that was as if this was a whole complete square. But I don't have that. I am missing this piece right here.
Well,
And where did I get the piece that I was missing was 3 by 8. That's where the 24 came in. The piece that was missing, the area of the piece that was missing was a 3 by 8 piece that was 24. So that's where that came from. And again, if that doesn't go for you, always do it this way. Okay, and I'm just throwing at you if you're thinking a little out. I mean, if that makes sense to you, then you can feel free to do it your way. It's not always my way or the express way.